next method now. Neutralizing an acid with a soluble base. Neutralizing an acid with a soluble base. It means, so that is a neutralized reaction when acid reacts with the soluble base. Not insoluble base, soluble base. When acid reacts with the soluble base, it will form the product salt. Okay. So acid plus soluble base will form the salt and water. So next method, preparation of salt, the fourth method. Okay. Neutralizing reaction. That is a neutralizing reaction because we are getting salt, no? So that is a neutral. So P is showing 7. Is it? So it is a neutral. So how the reaction takes place when acid reacts with the soluble base? Acid reacts with the soluble base. So it will form salt plus water. It will form salt plus water. For example, so nitric acid reacts with the NaOH. HNO3 acid. So it is acid, nitric acid reacts with the base, soluble base. So NaOH, that is the soluble base. It will form the salt. Can you guess the product? What will be the product there? Yes, sodium nitrate, NaNO3 plus H2O. Okay, this is the salt. This is the salt. So, how to prepare the salt there? So, it's a neutralizing reaction. When acid reacts with soluble base, we will use the salt and water. So, one example and one more. When HCl, hydrochloric acid, reacts with the NaOH, we know that after this one, HCl reacts with the NaOH, right? Sodium hydroxide, it will form sodium chloride, NaCl plus water. Sodium chloride plus water. Is it? So, sodium chloride, that is also a salt. So, salt is prepared by reacting with acid with soluble base. Sodium hydroxide is the base, so it is a soluble base. Okay. So, this is the fourth method for the preparation of salts. Neutralizing reaction, acid reacts with the soluble base. Okay. Next method now, when acid reacts with the insoluble base. So that is also a neutralizing reaction. So when acid reacts with the insoluble base. Insoluble base. For example, when hydrochloric acid reacts with the magnesium oxide. Magnesium oxide, it forms magnesium chloride. The fifth method, so when acid reacts with the insoluble base, it will use salt and the same product, water. Salt and water. Okay. For example, acid, hydrochloric acid reacts with the magnesium oxide. So this is the base. This is magnesium oxide. That is the base. It is insoluble base. Insoluble base. So when it reacts, it will form the magnesium chloride. MgCl2 plus water. Magnesium chloride plus water. So we need to balance the equation. So equation is balanced. Okay. So this is the salt. Magnesium chloride is a salt. Is it? So preparation of salt when acid reacts with the insoluble base. Insoluble base. Clear? And one more example. Nitric acid reacts with the lead oxide. Nitric acid reacts with the lead oxide. PbO, lead oxide. Nitric acid reacts with the lead oxide. It forms lead nitrate. Lead nitrate plus water. Okay. Yeah, lead oxide is a soluble base or insoluble base? now the next method, sixth method for the preparation of salt by the action of alkalis on certain metals. By the action of alkalis on certain metals. Okay, alkalis. Alkalis, strong alkali, weak alkali. Okay, all alkalis are bases, but all bases are not alkalis. I told in the previous classes. Is it? Yes. So now the next method, the sixth method, by the action of alkalis. Alkalis, NaOH or KOH, strong alkalis. Here we will take the NaOH or KOH, sodium hydroxide or potassium hydroxide, strong alkalis with the some of the metals. Okay. So the sixth method, reaction or action, not reaction, action of strong alkali, that is NaOH or KOH with active metals. Okay, so for example, when zinc reacts with the sodium hydroxide, zinc is a metal, reacts with the alkali, sodium hydroxide. This is a strong alkali. It will form sodium zincate. What is the formula of sodium zincate? What is the formula of sodium zincate? Don't know. Na2Zn O2 plus hydrogen will be liberated. Okay, so we have 2. Okay, so this is sodium zincate. Salt is sodium zincate. Na2Zn O2. That is the sodium zincate. Okay, so one more. When zinc oxide reacts with potassium hydroxide, zinc oxide reacts with potassium hydroxide. So it is a strong alkali, will form potassium zincate, K2Zn O2, potassium zincate plus will liberate the hydrogen. Equation. Yes. So these are the two methods for the preparation of the salts. By the action of strong alkalis on metals. Okay. Here zinc reacts with the sodium hydroxide. That is the alkali. It will form the sodium zincate. This is a salt. Salt plus hydrogen will liberate it. Similarly, zinc oxide. So it is a metallic oxide, and metallic oxide reacts with the potassium hydroxide. So alkali, it will form potassium zincate plus hydrogen will be there. Okay, so these are the few methods for the preparation of soluble salts. Okay, now next I will move to the preparation of insoluble salts. What you learned from the last class is the preparation of soluble salts. Now preparation of insoluble salts. Preparation of insoluble salts. Okay, so metal, the first method, by the direct combination we can prepare the insoluble salts. When metal reacts with the non-metal, will form the salt. So by direct combination, the first method, by direct combination. Okay, so when metal reacts with the non-metal, it will form salt. Insoluble salts by direct combination when metal reacts with the non-metal. So for example, when metal, so take one metal, I will take their lead reacts with the sulfur, it forms lead sulfide. So metal, so lead is a metal, non-metal, sulfur I will take that. So when these two react, they will form lead sulfide. So this is the lead sulfide. Be careful there. Lead sulfide, only one S is there, one sulfur is a sulfide. Okay, clear? SO3 sulfide, SO4 sulfate. Okay, don't get confused. SO2 sulfur dioxide. Okay, so the next one more. So an iron reacts with sulfur, electric sulfide forms ferrous sulfide. So this is a salt. These two are salts. So insoluble salts. These are insoluble salts. Insoluble. Okay. Insoluble salts. So we are preparing the insoluble salts only. So how to prepare that one? When metal reacts with non-metal. For example, lead reacts with sulfur, it becomes lead sulfide. Iron reacts with sulfur, it becomes iron sulfide. Okay, so it is a combination reaction. Is it? It is a combination reaction. What is the combination reaction? It is combined to give a single product. Is it? That is a combination reaction. Everything forgot. Yes. Move to the next method now. By the combination of an acidic oxide with a basic oxide. By the combination of acidic oxide with a basic oxide. Basic. So both acidic oxide and basic oxide, if they combine, they are forms the insoluble salts. For example, first one, sulfur dioxide reacts with calcium oxide. The second method, by the reaction of acidic oxide with basic oxide. By the reaction of acidic oxide with the basic oxide. For example, when sulfur dioxide reacts with the basic oxide, that is calcium oxide. Calcium oxide. So what it will form there? What will be the product? Can you guess the product there? Can you guess the product?
Calcium sulfate.
Yeah, calcium sulfide. SO3, no, calcium sulfide. Calcium sulfide. That is an insoluble salt. So this is a acidic oxide. So this is a basic oxide. When acidic oxide reacts with basic oxide, it will form the insoluble salt. Insoluble salt. Okay, that is calcium sulfide. One more. When carbon dioxide reacts with the calcium oxide, it forms calcium carbonate. Okay, so when carbon dioxide reacts with the calcium oxide, it forms the calcium carbonate. That is also a salt, insoluble salt. It is insoluble salt. Okay, so these are the two methods for the preparation of the insoluble salts. Okay. Next, one more method, by the precipitation reaction. What do you mean precipitation reaction? Precipitation reaction. Okay. For example, when barium chloride reacts with the sulfuric acid, it forms barium sulfate. We know this one, is it? By the precipitation reaction, when barium chloride reacts with the sulfuric acid, H2SO4, it will form barium sulfate. Plus what? Barium sulfate plus 2HCl. So this is it. So downward arrow Silver chloride. Silver chloride. That is also insoluble salt. It means that is not soluble in that solution. Okay. So it's silver chloride. So how to prepare the silver chloride? When silver nitrate reacts with the hydrochloric acid. When silver nitrate reacts with the hydrochloric acid, it forms the silver chloride. So second one, silver nitrate reacts with the HCl. It is a dilute. Both here also very important reaction sulfuric acid is a dilute, not concentrated. Dilute acid. Dilute acid. This is also dilute acid. Do not take concentrated acid. Okay. So dilute acid. Okay. So it forms the AgCl, silver chloride plus what is the product? Another product. AgCl, HNO3 nitric acid. HNO3 it forms. So this is the salt. This is the salt. Okay, insoluble salt. Clear? So one more, when copper sulfate reacts with the hydrogen sulfide. More reaction. It is a precipitation reaction. Copper sulfate CuSO4 reacts with the hydrogen sulfide H2S. It will form copper sulfide CuS plus sulfuric acid. Sulfuric acid. So this is a salt, insoluble salt. So downward arrow it means it is a insoluble. Downward arrow indicates insoluble in that solution, in that aqueous solution. Okay. So these are the methods. So three methods I told for the preparation of salts. Is it? Three methods. First one is a by combination reaction. Second one is a by the combination of acidic oxide with the basic oxide. By the combination of acidic oxide with the basic oxide. Okay. Next one more method for the preparation of insoluble salts by the precipitation reaction. When barium chloride reacts with the dilute sulfuric acid, dilute, not concentrated, dilute sulfuric acid, it will form the barium sulfate. Downward arrow indicates is a insoluble in that aqueous solution. Okay, and it will form the acid HCl. So one more. So silver chloride. How silver chloride is formed? When silver nitrate reacts with the hydrochloric acid. So it is a dilute acid. Again, it is a dilute acid. It forms the silver chloride plus nitric acid. Okay. So these are the few methods for the preparation of salts. Next, laboratory preparation of some salts. Laboratory preparations. Before going to the laboratory preparations, carbonates. So some carbonates also, calcium carbonate, magnesium carbonate, zinc carbonate. So they are also insoluble salts. How to prepare the insoluble salt? For example, when zinc sulfate reacts with the, how to prepare that one insoluble carbonate salts. Okay, insoluble carbonates. Most of the carbonates are insoluble. They can be prepared by boiling that metal salt with the sodium carbonate. So how to prepare that one? By boiling metal salt with the sodium carbonate. By boiling metal salt with the sodium carbonate. Metal salt. So one example I will give that. So metal salt, zinc sulfate. So it is a metal salt because here zinc is a metal. Okay, metal salt reacts with the sodium carbonate. CO3 sodium carbonate, it forms zinc carbonate. Na2SO4 sodium sulfate is one product, and zinc carbonate. So this is the insoluble salt. So zinc carbonate is an insoluble salt. When barium chloride reacts with the sodium carbonate. Barium chloride. Sodium chloride, that is a soluble salt. Sodium chloride, it is a soluble salt. Okay. And one more product, that is a barium carbonate. That is insoluble salt. This is a insoluble salt. Okay. Insoluble sodium chloride, that is soluble salt. But carbon, so we are talking about the carbonate salts. So barium carbonate, that is the insoluble salt. Okay. So these are the few preparation of insoluble salts, and few laboratory preparations also is there. It is given in your textbook. Laboratory preparation of some salts, so you can read yourself. Okay. So it is very, you have to do in the laboratory. So when it will open, means when the school will open, let's see that time you can do in the laboratory. Okay. So it is a practical, not theoretical. It is a practical method for the preparation of salts. Practical methods. So some of this preparation they gave: iron chloride. Okay. Next zinc sulfate and iron sulfate. Zinc sulfate and iron sulfate. So many salts they gave. Okay. So you can go through your textbook there, read once.